In 1942, Germany stood at the absolute zenith of its terrible power. The map of Europe was painted in swastikas, a vast, oppressive canvas stretching from the blustery, concrete pillboxes of the Atlantic Wall to the endless, muddy, and frozen fields deep within the Soviet Union. The Großdeutsches Reich was not merely a state, it was a colossal edifice of conquest spanning half a continent, commanding the resources of captive nations. London was a city bruised but defiant, suffering nightly raids but refusing to break. Moscow was a city clinging to life by a thread, its defense purchased with unimaginable sacrifice. The Wehrmacht had shattered military convention, proving that speed, mechanized terror, and the sheer audacity of an offensive mind could render the established doctrines of centuries obsolete. They had perfected the Blitzkrieg, the lightning war, a doctrine of deep penetration and psychological shock. This stunning success masked a fatal, structural weakness. At the Reichskanzlei in Berlin, in the bunker complex beneath the city, the Führer, Adolf Hitler, was already looking beyond the visible horizon of territorial victory. The current war, he believed, was a mere preliminary skirmish. A greater, more fundamental, and vastly more technological conflict, a war of total annihilation, was yet to come. The goal was not merely the occupation of territory, but the total subjugation of the enemy's will, the imposition of a technological dominance so complete it would ensure a 1,000-year Reich. The subtle, cold fear that began to creep into the halls of power was a simple economic equation: manpower versus mobilization. The American entry into the war, triggered by the attack on Pearl Harbor, was the deafening clock that Hitler could hear ticking. The war of tanks and infantry was being won by Germany today, but the war of production, the relentless, exponential war of steel, oil, aluminum, and manpower, was a contest Germany could not sustain against the coming, unbridled mobilization of the New World. America, the sleeping giant, was awakening, its assembly lines gearing up to churn out staggering numbers of ships, planes, and tanks, a quantitative flood against which German qualitative superiority would eventually drown. Therefore, the only path to permanent, unassailable dominance lay not in mass production, but in the quantum leap. The sheer volume of Allied factories had to be rendered irrelevant by the qualitative superiority of German science. This necessity became a mania. The Führer demanded a new category of weapon. The Wunderwaffe, the miracle weapon, machines so advanced they would not just win battles, but instantaneously turn back the tide of war, forcing capitulation through sheer technological terror. This was the genesis of a desperate, sprawling intellectual war fought not with tanks or soldiers, but with radical, revolutionary ideas. It was a Faustian bargain: absolute, immediate victory in exchange for every last strategic resource and, ultimately, the moral integrity of the nation's scientific soul. By mid-1942, the strategic situation had solidified into a paradox. Germany was outwardly a monolithic fortress, yet the first cracks were appearing in its industrial and logistical foundations. The Luftwaffe, the proud victor of Poland and France, was now locked in a grinding, attritional war against the sheer, endless rotation of Anglo-American airpower. The Messerschmitt Bf 109 and the Focke-Wulf Fw 190, superb piston-engine fighters, were magnificent today, masters of the air in a dogfight. But reconnaissance photos and intelligence reports filtering back to Berlin suggested Allied designs for faster, more powerfully armed future aircraft, hinting at a technological parity that would soon become supremacy. Hitler, an autodidact with a profound, almost childlike fascination for engineering and architecture, but deeply suspicious of theoretical physics, especially anything he considered Jewish science, like the theoretical foundation of nuclear power, placed his total faith in the visually spectacular and the immediately terrifying. He was not interested in marginal improvements, he was obsessed with speed, range, and size, weapons of intimidation that reflected his own megalomania. This obsession became the absolute mandate for his engineers, men like the ambitious rocket scientist Wernher von Braun, the aerodynamic pioneer Willy Messerschmitt, and the automotive titan Ferdinand Porsche. They were not merely asked to improve upon existing designs, they were instructed to build machines that belonged to the next century. A weapon that could destroy the enemy's confidence before it even left the ground. The scientists and engineers, gathered in secret facilities across the Reich, from the wind-swept, isolated testing grounds of Peenemünde on the Baltic coast to the heavily disguised factory halls of Bavaria, were handed a poisoned chalice. They had unlimited resources in theory, a blank check from the War Ministry, but were shackled by impossible deadlines in practice. Their genius was fueled by the darkest urgency of a nation realizing, belatedly, that its window of opportunity was rapidly closing. They were about to deliver the miracles the Führer demanded, but the price, financial, human, and moral, would be staggering. The reality of 1942-1943 was defined by the transition from mechanized warfare to a grueling contest of attrition. To escape this trap, German scientists pushed technology far beyond its known physical and material limits, driven by the seductive promise of bypassing the present altogether. They were inventing entirely new disciplines of warfare, forcing the very elements, air, heat, and sound, into submission. The fire of the future, jet propulsion. The most immediate and spectacular of these revolutionary leaps was the development of the turbojet engine. While the British had pioneered the concept with Frank Whittle and the Americans were catching up, the Germans were the first to operationalize and deploy a jet aircraft in combat. The Heinkel He-178 first flew in 1939, but the true breakthrough came with the powerful, though flawed, axial flow engines designed by Hans von Ohain Heinkel and Anselm Franz Junkers. The jet engine, a gas turbine that devoured air and spewed thrust, offered the one thing that piston fighters could never match: supremacy of speed. The Messerschmitt Me 262 Swallow was the direct, terrifying result. It was a fighter that looked and behaved like something from an entirely different war. Cruising at over 540 miles per hour, it was routinely 100 miles per hour faster than the best Allied propeller fighter, the North American P-51 Mustang. They built jet fighters when the world still flew on propellers. The Schwalbe was less an aircraft and more a high-speed projectile, bristling with 4 deadly 30mm cannons. Test pilots spoke in hushed awe of the feeling of leaving the entire atmosphere of the war behind, of watching Spitfires and Mustangs hang in the air like stationary targets as they flashed past. However, the reality of the race was harsh. The first jets suffered catastrophic material failure. The extreme heat and rotational stresses generated by the turbines demanded perfect nickel and chromium alloys. Germany's dwindling access to these strategic metals, compounded by Allied bombing of metallurgical plants, meant that engineers were forced to use inferior, often synthetic materials. As a result, the Me-262's Jumo 004 engines often lasted only 10 to 25 hours before requiring a complete overhaul or, worse, suffering a catastrophic flameout or turbine blade failure mid-flight. Furthermore, the engines were notoriously prone to compressor stall if throttled too quickly, a common event in dogfighting, instantly turning the advanced jet into a 15,000-pound glider. The geometry of speed, swept wings and the sound barrier. Beyond the engine, German engineers were pioneering the most vital aerodynamic concept of the late 20th century, the swept wing. Led by figures like Woldemar Voigt at Messerschmitt, they recognized that as aircraft approached the speed of sound, the sound barrier, then considered an almost unbreakable ceiling, the air would pile up, creating intense shockwaves and drag. By sweeping the wings back around 35 degrees, as seen in the later Ta-183 Huckbane design, they could effectively fool the air into perceiving the wing as traveling slower than it actually was, pushing the critical Mach number higher. They experimented with rocket-powered aircraft, guided missiles, and tanks too heavy to even cross a bridge. In their feverish pursuit of perfection, the basic constraints of physics, logic, and even sanity became terrifyingly optional. Every project promised instantaneous victory, a single, decisive weapon to end the grinding war, but the majority ended in costly, spectacular disaster. The pursuit of the miracle was eroding the very resources needed to win the conventional war. The story of the Me-262 perfectly encapsulates this race against reality and the self-destructive interference of the regime. It was ready in prototype form by 1941, but its introduction was fatally delayed by a cascade of mistakes: bureaucratic infighting between the Luftwaffe and the Air Ministry, technical difficulties with the engines, and, most critically, Hitler's own strategic blunders. When the aircraft was finally ready for mass production in 1944, Hitler, in a catastrophic display of misplaced authority, demanded it be used not as a fighter, but as a high-speed, light bomber, Blitzbomber, a role for which it was ill-suited. This decision, driven by the Führer's obsession with immediate retaliation against Allied bombing raids, cost the Luftwaffe critical months. The aircraft's high speed made accurate horizontal bombing impossible, and its deployment as a fighter was stalled while precious resources were wasted on modifying it into an ineffective bomber. By the time it was finally permitted to operate as a pure interceptor, the Schwalbe was too few in number, and the tide of war had long since turned. The jet pilots were magnificent, shooting down Allied formations with shocking efficiency, but they were a handful against the thousands of Allied bombers and escort fighters. The jets were vulnerable during their two most crucial phases, takeoff and landing. Allied pilots, realizing they couldn't catch the jets at high speed, learned to patrol the German airfields, picking off the slow-moving, vulnerable Schwalbes like vultures. The genius of the jet was neutralized by the overwhelming numbers and simple operational realities. The future had arrived, but the past was simply too numerous to be ignored. The jet program was only the beginning of the Luftwaffe's obsession with total speed and invisibility. The Horden flying wings. Far more radical were the designs of the Horden brothers, Riemer and Walter. Inspired by pure aerodynamic efficiency, they designed the Horden Ho 229, a twin-jet fighter bomber shaped like a sleek, black boomerang. It dispensed entirely with a traditional tail, using its unique shape to minimize drag. Crucially, the aircraft's blended wing design, constructed largely of wood and carbon-impregnated glue, offered an unintended bonus, a reduced radar cross-section. The Ho 229 was arguably the first jet aircraft to possess stealth characteristics. It was truly a ship from another world, promising unmatched performance. Only a handful of prototypes were ever constructed before the war ended, but they represented the pinnacle of aerodynamic purity. Guided ordnance. German engineers also pioneered the modern concept of the guided missile. The Fritz X and the Henschel HS-293 were the world's first operational anti-ship guided weapons. The Fritz X was a radio-controlled armor-piercing bomb, used successfully to sink the Italian battleship Roma in September 1943. The HS-293 was a rocket-boosted glide bomb used against Allied convoys. These weapons demonstrated devastating precision, but they required the launch aircraft to fly straight and level while the operator guided the missile via radio link, a highly vulnerable task under heavy Allied fighter cover. Like all Wunderwaffe, they were deployed too late and in insufficient numbers to be a strategic threat, but they permanently changed naval and aerial warfare. While the Luftwaffe dealt with the air war, a far more chilling and isolated project unfolded on a remote strip of the Baltic coast. At Peenemünde, the Army Research Center, the most brilliant minds in German rocketry were creating the V-weapons, the first true ballistic missiles and the opening shot of the space age. The operation was led by the young, ambitious, and charismatic Werner von Braun and the experienced artillery officer General Walter Dornberger. Von Braun, driven by a boyhood obsession with space travel, saw the war not as a political conflict, but as a regrettable, yet necessary, means to fund his ultimate dream, reaching the moon. Peenemünde was less a military facility and more a scientific cloister, filled with physicists, chemists, and mechanics working in an environment of intellectual fever, shielded from the worst excesses of the Nazi bureaucracy, for a time. The V-2 rocket, or AGGREGAT-4A4, as it was designated internally, was the child of this environment. It was a masterpiece of electromechanical engineering, a 14-ton missile, standing 46 feet tall, powered by a massive engine fueled by highly volatile liquid oxygen and alcohol. It was the first human-made object to achieve sustained supersonic flight and the first to enter the fringes of space. It was capable of reaching an altitude of 50 miles, placing it firmly in the lower thermosphere, decades ahead of its time. It was a triumph of engineering, and a nightmare of morality. The rocket flew so high and so fast, reaching speeds over 3,500 miles per hour, that it arrived without warning. There was no defense, no siren, no opportunity for shelter. The sound of its approach arrived after the explosion. It was the embodiment of Hitler's demanded terror weapon, the Vergeltungswaffe, vengeance weapon. The first V-weapon deployed was the V-1 flying bomb, Fieseler Fi 103, a smaller, cheaper, pulse jet-powered cruise missile nicknamed the Doodlebug. The V-1 was a weapon of mass harassment. It was slow enough to be intercepted by fighters and anti-aircraft fire, and its distinctive, throbbing engine would famously cut out just before its final, terrifying dive, giving its victims a few agonizing seconds of silence before impact. Between June 1944 and March 1945, over 9,500 V-1s were launched at Britain, killing over 6,000 people and causing immense psychological distress. But the V-2 was the true marvel. Launched first in September 1944, Aimed primarily at London and Antwerp, over 3,200 V-2s were launched during the war. Each rocket carried a ton of high explosives, but the real damage was psychological, the silent, unpredictable nature of its arrival. The moment of impact was the first warning. The engineering challenges overcome were immense. The V-2 required developing sophisticated turbopumps capable of feeding fuel and oxygen to the combustion chamber at a rate of 280 pounds per second, a feat that rivaled modern engineering standards. It needed a fully autonomous inertial guidance system using gyroscopes and carbon vanes placed directly in the exhaust plume to steer the rocket in flight. The genius of the V-2 was indisputable. The production of these rockets, however, constitutes one of the darkest and most morally bankrupt chapters of the war. The sheer logistical scale of manufacturing thousands of V-2s required moving production underground, safe from relentless Allied bombing. The primary site became Mittelworks, an immense, secret factory complex carved into the Kohnstein mountain near Nordhausen. This vast, cold network of underground tunnels, originally a gypsum and shale mine, was converted into a technological sanctuary but a human slaughterhouse. The facility fell under the operational control of SS General Hans Kammler, a cold, efficient engineer who answered directly to Heinrich Himmler and was perhaps the most ruthless manager in the entire Wunderwaffe program. Kammler's solution to the labor shortage was simple and brutal: enslavement on an industrial scale. The labor force consisted entirely of forced laborers and prisoners of war, primarily Soviet POWs, Polish intellectuals, French resistance members, and Jewish prisoners from the nearby concentration camp, Dora Mittelbau. The conditions were indescribably brutal. Prisoners, often clad in rags and forced to work 18-hour shifts in the dust-choked, freezing tunnels, slept in rudimentary bunks built into the damp rock walls. Starvation, dysentery, and pneumonia were endemic. The constant, arbitrary violence of the SS overseers and Kapos prisoner functionaries meant that survival was a statistical anomaly. Underground tunnels filled with forced laborers, thousands dying to build Hitler's so-called wonder weapon. The irony was horrific and absolute. The most advanced weapon ever conceived by man, designed to usher in a technological future, was being built by the most primitive, inhumane labor system imaginable. It is estimated that at least 20,000 prisoners died at Dora Mittelbau during the V-2 production cycle, a number that actually exceeds the total number of people killed by the V-weapons in Allied countries, approximately 9,000. The moral price for the Wunderwaffe was paid in the lives of the slave laborers before a single missile ever reached its target. This was the ultimate cost of Hitler's dream. Even as the V-weapons were deployed, the most ambitious project was already underway, the Amerikabomber program. If the V-2 could reach London, Hitler demanded a weapon that could strike the source of Allied industrial power, New York and Washington, D.C., thereby shattering American morale and forcing a cessation of hostilities. This concept led to fantastic, desperate designs that seemed to defy gravity and distance. The Silbervogel, Silver Bird, the most revolutionary design, conceptualized by Eugen Sanger and Irene Brett. It was a suborbital spaceplane, a winged rocket that would be launched on a massive sled, boosted to extreme velocity, and then skip off the upper atmosphere like a stone skimming water, enabling it to cross the Atlantic and bomb the east coast of the United States before gliding back to Europe. It was the most visionary and impossible proposal of the war, a design that would directly influence the American Dinosaur program and the concept of reusable spacecraft decades later. The Junkers Ju-390, a massive, six-engined long-range reconnaissance aircraft. It was so large it required specialized, reinforced runways. While never officially deployed for a transatlantic bombing mission, one prototype allegedly made a secret, unverified flight in early 1944, reaching within sight of New York before returning, a massive psychological operation that, even if fabricated, symbolized the dark, impossible ambition of the Reich. The demand for impossible technology extended to the ground war, where the philosophy of qualitative superiority gave birth to designs of staggering absurdity and logistical nightmare. The Maus tank, designed by Ferdinand Porsche, was the ultimate expression of Hitler's love for size. Weighing a colossal 188 tons, the Panzerkampfwagen 8 Maus was intended to be an impenetrable mobile fortress, armed with a 128mm cannon and a secondary 75mm gun. Its scale defeated its purpose. It was so heavy that it could not use the existing European road network, could not be transported by rail without specialized, purpose-built carriages, and was too massive to cross virtually any European bridge without it collapsing. Its speed was a pitiful 8 miles per hour. 2 prototypes were built, but the Maus represented a complete breakdown of military logic, a vehicle that defeated its own purpose by being too massive to engage in modern, maneuverable warfare. The Landcruiser P-1000 Rat even more preposterous was the conceptual 1,000-ton Rat, a land battleship designed to mount naval artillery, requiring a crew of over 40 men. This was a drawing board fantasy, but the resources and planning hours diverted to such ludicrous, unfeasible projects were a criminal waste in a nation starving for basic truck and fuel production. What Hitler called impossible made real was, in truth, a death sentence for the engineers forced to deliver miracles in months, not years. The desperation of late 1944 spawned a new wave of radical, high-risk interceptors, each a beautiful death trap. The Heinkel He-162 Volksjäger, People's Fighter, as the Allies achieved total air dominance, the call went out for a disposable jet fighter, cheap, quick to build primarily from wooden non-strategic materials, and simple enough to be flown by Hitler Youth pilots given minimal training. Its entire development cycle, from blueprint to first flight, took less than 90 days. The result was an elegant, unstable machine. Its poor construction and lack of experienced pilots meant that many young flyers crashed due to structural failure or on landing before ever seeing combat. It was the ultimate, tragic expression of technological desperation coupled with human sacrifice. The Messerschmitt Me-163 Comet, perhaps the most radical fighter ever fielded. A rocket-powered interceptor designed by Alexander Lippisch, it was powered by volatile, hypergolic propellants known as C-Stoff and T-Stoff that ignited instantly upon contact. The Comet could climb vertically to bomber altitude faster than any other aircraft on Earth, reaching 40,000 feet in under 3 minutes. It was literally a manned missile, but its rocket fuel was terrifyingly dangerous, frequently exploding on the ground or in the air, dissolving pilots who accidentally spilled it on their skin. The plane had no engine for the return journey, forcing the pilot to glide back to the airfield, making it a sitting duck for Allied patrols. The Comet killed far more of its own pilots in accidents than it ever killed Allied airmen in combat. The high stakes of the Wunderwaffe program created a toxic climate of fear and paranoia that bled the scientific community dry. Under the totalitarian regime, failure was not merely a design flaw, it was a political offense, often equating to sabotage or treason. Engineers and scientists, driven by a complex mixture of genuine scientific curiosity, patriotic fervor, and existential fear, worked under the direct, often manic, control of the Führer, bypassing the standard checks and balances of military procurement. When an impossible deadline was missed, or a costly prototype failed, the consequences were swift and often fatal. Many of those who couldn't deliver simply disappeared. Engineers who dared to argue with Hitler's non-scientific mandates, such as Willy Messerschmitt's attempts to use the Me-262 as a pure interceptor rather than a bomber, found themselves marginalized, investigated by the Gestapo, or threatened with conscription to the front lines. The entire process was complicated by the constant war within a war among rival Nazi power centers. Albert Speer's Ministry of Armaments attempted to rationalize and centralize production, realizing the inefficiency of the system. Hermann Göring's Luftwaffe desperately fought to retain control of the jet projects. Heinrich Himmler's SS, through Hans Kammler, aggressively sought to seize control of all the weapons and strategic production, viewing the scientists as mere servants and the slave labor as a disposable asset. The intellectual creativity of the German scientist was shackled by the political paranoia of the regime. The constant stress, the fear of the Gestapo, and the moral burden of the slave labor used to build their creations all took a shattering toll. In one crucial area, the Wunderwaffe program failed to deliver its ultimate terror, the atomic bomb. While the Allies poured $2 billion into the Manhattan Project, Germany's equivalent, the Uranvariant Uranium Club, was fragmented, underfunded, and often misdirected. Key physicists like Werner Heisenberg and Carl Friedrich von Weizsäcker made fundamental calculation errors regarding the amount of fissile material needed, and they often clashed with the regime. Furthermore, Hitler and the Nazi leadership, fixated on immediate battlefield results, saw the years-long, massive investment required for nuclear power as too distant and theoretical. They opted instead for the visually spectacular and immediately achievable V weapons. This decision, driven by prejudice and impatience, proved to be Germany's greatest strategic mistake, saving the world from the horror of nuclear war in European theaters but ultimately dooming the Reich by failing to match the American technological ultimate weapon. The deployment of the V-weapons, while psychologically terrifying, signaled to the Allies that a new, dangerous technological race was underway. This initiated the Allied intelligence and military response known as Operation Crossbow. Intelligence gathered, often from double agents and photographic reconnaissance, pinpointed the primary research site. In August 1943, Operation Hydra launched a massive bombing raid on Peenemünde. While not entirely crippling the facility, the raid forced the dispersal of the rocket program underground to Mittelwerk and fatally delayed the V-2's operational deployment. The intelligence war became as fierce as the air war, with Allied teams tirelessly hunting down mobile V-1 and V-2 launch sites, often hidden in dense forests or in urban areas. The resources the Allies dedicated to neutralizing the Wunderwaffe were a testament to the fear these weapons instilled, but the effort further diverted German resources away from producing conventional defenses. By the turn of 1945, the vast industrial infrastructure of the Wunderwaffe program lay scattered across ruined airfields and burned-out factories. The V-2 launch sites were overrun by the Red Army. The Mi-262 factories were bombed into rubble. The Maus tanks were abandoned, self-destructed by their crews to prevent capture. The final act of the Wunderwaffe drama was the desperate, cynical attempt by the Allies, both East and West, to capture the most valuable asset remaining, the human capital. The last months of the war saw a frantic scientific scramble, a competition for the spoils of German intellect that historians call the technological plunder. Operation Paperclip USA, the most famous operation, was the American mission to secure Germany's rocket scientists. Led by intelligence officers, Operation Paperclip systematically identified, recruited, and exfiltrated over 1,600 German scientists, technicians, and engineers to the United States. The goal was twofold: to deny these mines to the Soviet Union and to accelerate American technological dominance. Wernher von Braun, along with his entire rocketry team, famously surrendered to the Americans in Bavaria, declaring that he wished to ensure his rockets were used to build the new world, not destroy it. The surrender was a calculated geopolitical move to protect their future and their life's work. Soviet trophy teams. The Soviets were equally, if not more, aggressive. They seized control of the devastated Peenemünde research facilities and the entire Mittelwerk Dora complex. They rounded up thousands of engineers, machinery, and blueprints. Key figures like Helmut Grotrup, a leading deputy to von Braun, were forced to move to the Soviet Union, where they continued their rocketry research under intense military supervision, directly contributing to the Soviet satellite and ICBM programs. Other operations, like Operation Lusty, saw Allied teams meticulously ransacking aircraft facilities to gather every blueprint, engine, and flying wing design. The capture of these mines marks a chilling, immediate transition from the World War to the Cold War. Von Braun's rockets would take America to the moon. The entire von Braun team, now operating out of Huntsville, Alabama, became the foundational core of the American space program. The V-2 was reverse-engineered into the Redstone missile, which became the launch vehicle for America's first satellite and first astronaut. The legacy of Peenemünde directly fueled the Saturn V rocket that took men to the moon. The moral reckoning of using men whose hands were stained with the knowledge of Dora Mittelbau was conveniently deferred by the geopolitical imperative of the Soviet threat. The moral compromise was justified by the need to win the space race. Others vanished behind Soviet lines, building the Cold War's deadliest weapons. Scientists captured by the Soviet Union were instrumental in developing the early Soviet ICBM program, creating the rockets that would launch Sputnik and eventually Yuri Gagarin. The technological leap, intended by Hitler to ensure a thousand-year Reich, instead became the immediate, terrifying foundation for the next global conflict. The very minds that once tried to win Hitler's war would go on to shape the next century, driving the nuclear arms race, the space race, and the revolution in modern aviation. The tragedy of the Wunderwaffe was not that the technology was flawed, it was undeniably brilliant, a premature window into the future, but that the entire effort was fundamentally misplaced and fatally late. The allocation of massive, irreplaceable resources, nickel, chromium, specialized fuels, skilled labor, and precious intellectual focus, to these complex, slow-to-deploy systems deprived the conventional war effort of the materiel it desperately needed. 1,000 more simple, reliable Messerschmitt Bf 109s or Focke-Wulf Fw 190s, built quickly and simply in 1943, would have had a measurable impact on the air war. The V-2, for all its terror, was a psychological weapon, not a strategic one. It consumed more resources and killed more slave laborers in its creation than it delivered damage to the enemy. The German Wunderwaffe program remains a terrifying and compelling case study in the perils of technological hubris and totalitarian control. It proves that technological genius, divorced from logistical reality, ethical constraints, and rational military doctrine, becomes a destructive force not only for the enemy but, ultimately, for the nation that unleashes it. The German dream of supremacy ended not with a glorious miracle, but with the haunting shriek of a rocket engine disappearing into the heavens, its promise of victory a hollow echo, its legacy a nightmare of fire, steel, and forgotten graves.